So in this problem, it is saying that armature voltage of 100 volt. Armature voltage means terminal voltage, that is 100 volt at rated field winding voltage, right? Why rated? To operate in constant torque region, we always need rated flux, right? In field weakening region, we reduce the flux, but flux cannot go beyond rated because the reason behind is one is saturation, and other it will take lot of current, so that our efficiency would drops. So flux is equal to phi rated. A speed is given 1000 rpm, and it is driving a fan. So it is a fan kind of load, and fan kind of load has some torque speed characteristics. So its load is proportional to the square of the rotor speed. Okay, so load torque is
अच्छा तो
proportional.
ये हाँ जी भाई पानी ये ठंडा हो गया थोड़ा बता रखी हाँ
Yeah, now Kirti, you are trying to ask
जी
anything.
हाँ जी पूछ
I think you are unmuted by mistake, I guess. I am muting yourself. Okay, so so load torque is depending on speed of your rotor, and generally in from machine side, if you see, this is the requirement of load. This much torque the motor should be capable of delivering, but machine torque depends on current, right? Current and flux. So armature current and flux, right? So this is the characteristics when both field MMF and armature MMF is 90 degree, then torque is maximum. So this torque is depending on this electromagnetic torque, which will be produced by motor. So that depending on armature current and flux. And here the load torque is dependence of rotor speed ka square, and we need to find what will be the value of armature voltage, which will reduce the rotor speed to 500 rpm. So earlier rotor was running at 1000 rpm. Let me call it speed 1, N1. Now we need to reduce the speed of motor to 500 rpm. So how we can do? We all know the speed is dependence of back EMF. Whenever a speed term will come, you can see speed depends on back EMF, as well as back EMF depends on flux. So we have some constant, common constant. We know K phi omega. This is a very famous formula, and torque is equal to K phi IA. So torque dependence on flux and current, back EMF or induced EMF dependence on flux and speed. Okay. So first, initially speed was 1000 rpm. Now we need to reduce it to 500 rpm. What kind of flux or current or what kind of voltage will be there so that this speed will be reduced to 500 volt, 500 rpm level. So first, what we will do, we will calculate what was back EMF in first case. Earlier, what was the back EMF? So we all know it is a separately excited motor. It is mentioned explicitly. It is separately excited DC motor.
Excuse me, sir.
Yeah, please.
Sir, armature voltage should be equal to the back EMF.
How? Why?
I think.
Why you are saying
Sir,
so?
sir, armature voltage is the voltage appearing across the armature, and
Okay.
terminal voltage is the voltage which is applied across it.
Okay.
So yeah, in between a resistance is coming, na?
Uh-huh.
Then why you took the armature voltage as terminal voltage?
Yeah, I will explain it. So whenever we mention armature voltage, we mean by how much voltage you are applying, right? you cannot apply this voltage because this is motor. So this will be developed. You cannot apply this voltage, this back EMF, right? This you are calling, this you are saying that I should call it armature voltage, right? Whatever this voltage would be, armature voltage. But this is
Yes,
not the case. I will explain why. So there will be some RA. Okay. This is terminal voltage, and since it is motor, so current will draw from the supply. So, as you know, in motor or even in generator, in motor you have control on how much supply you give. You know, electrical input, mechanical output. Okay, so how much voltage you are supplying, that will come across the armature. So that's why we call it armature voltage, right? This is also the part of armature, right? So whatever the voltage you apply across the motor or armature, that we call it either armature voltage or supply voltage. So let me show you after solving it. You would appreciate it. Like it is correct what I am saying. VT is armature voltage. Once I will finish with this problem, you see, okay? Then if any doubt is there, you can ask. Fine?
yes,
Yeah. So E1 would be VT minus IA RA, IA1 RA, I would say, because what would be the current flowing in first case? So it is saying that earlier the armature current was 10 ampere. I hope you are able to follow the problem. So here armature current was 10 ampere when fan was driving 1000 RPM. Okay, so at 1000 RPM it was 10 ampere. So this is 10. RA was 1 ohm, I guess. So RA is 1 ohm. VT was 100 volt. So it would be 90 volt. This is E1. We calculated E1. We know the speed across it was 1000 RPM. Okay. When this armature was rotating at 1000 RPM, it was developing 90 volt. Okay. In second case, we know the speed is 500 RPM. Then what would be the back EMF and current if we can somehow if we can calculate back EMF in that case and current, armature current, then we will be able to calculate the armature voltage or supply voltage. Okay. So another information is given about the torque. Torque is given as n square. And since we know from the concept of DC motor or machine, it is proportional to pi Ia. And since a speed is reducing, it is not increasing from rated speed, right? It is reducing from 1000 RPM to 500 RPM. So it is still in constant torque region. We are not doing field weakening, so flux will still be constant. So it will be constant. So effectively, we can say the speed square is proportional to Ia. Now, we can write it as like that n1 square divided by n2 square is proportional to Ia1 by I. I hope it is fine till now. We know n1, we know n2. N2 is reducing to 500 RPM. We know Ia1. We can calculate Ia2. Fine. So I will do it, and Ia2 will be equal to Ia1 into n2 by n1 square. Ia1 was 10 ampere into a speed reduced was 500 RPM, a speed earlier was 1000 RPM, and I am doing here a square, so it would be 2.5 ampere. Okay. Ia2 we calculated. Now we need to calculate back EMF. right? E2 by E1 would be equal to N2 by N1. We are again ignoring flux since it is rated, so it will be constant. Even if you take phi 2 by phi 1, it is same, so it will cross out. Okay, so for that purpose, I will calculate E2, which will be equal to E1 into N2 by N1. And E1 we calculated, it was 90 volt. So 90 into a speed when it was reduced 500 divided by 1000, so it would come out to be 45 volt. So we completed our both the objective to calculate current, armature current and back EMF at the speed of 500 rpm. So at 500 rpm, now we need to calculate our armature voltage. So armature voltage would not be equal to back EMF. Why? Because now we need how much voltage we should apply so that the motor would run at this 500 rpm. Okay, so at 500 rpm, its induced EMF would drop up to 45 voltage, but our rated voltage was 100 volt, right? So if we leave our rated armature voltage at 100 volt and this 45 volt is reduced due to a speed, then current would flow would be 100 minus 45 by 1, that would be 55 ampere, and that is 5.5 times of rated current, which will not be acceptable. You got it, Anwar? Why we are calling it or why we are managing armature voltage? Because that's where we have the control. We do not have control on induced EMF because that will be dependent on a speed only. So for that purpose, we need control on supply side. And that's why it is asking how much, what is, how much armature voltage will be applied so that this motor speed will be reduced to 500 rpm. Okay, is it fine, Anubhav? Yeah, fine, thanks. So now, so this is not answer. This is not answer. This I was explaining. So at 500 rpm, I need armature voltage or terminal voltage, which I call. So it's VT2. Let me call it is equal to E2 plus IA2 into RA, and E2 we calculated 45 volt plus IA2 we calculated it's come out to be 2.5 ampere. So this is IA2 2.5 into 1, so which will be equal to 47.5 volt. So this will be your answer, how much armature voltage you can apply. So any doubt in this problem? So I will summarize it once again. In the problem, it was asked that the load torque is of the characteristics of fan and it is varying with the square of the rotor speed. Earlier, the rated condition was given. Rated voltage was 100 volt. Fan speed was 1000 rpm, or the motor which was driving the fan, its rated speed was 1000 rpm, and its rated armature current was 10 ampere. This is a separately excited DC motor. Now the armature resistance was also given. To reduce the speed from 1000 rpm to 500 rpm, what was the voltage we can apply? For that purpose, I did all the derivations and I showed you that how to calculate this type of problem. So I hope no doubt in this problem. If any, you can ask me. So if no any doubt in this problem, let me go ahead and solve some other problem as well.